Hello, everyone. My name is Luis Pollo, and I'm a software engineer at Netflix, where I work in the managed delivery team, which is part of our developer productivity organization. I am super excited to be here today with my friends Rob Hilton and Nima Kaviani from AWS to tell you the story of how we met in the Spinnaker open source corner of the world and how that led to a pretty fun and productive collaboration that has produced some really interesting results. I believe these will take Kubernetes support in Spinnaker to a whole new level. So let's get started. Here's what we'll be covering today. First, I'll do a quick recap of managed delivery and how it has evolved over this past year since it was first introduced in the 2019 Spinnaker Summit. Next, Rob will tell you about the evolution of Kubernetes support in Spinnaker and where we saw an opportunity to improve it. Then, Nima will talk about what we've built to integrate Kubernetes into managed delivery and discuss some further opportunities we see in this space. So let's do a quick recap of managed delivery. By the way, I highly encourage you to check out the talk from last year's summit by my colleagues Emily Burns and Rob Fletcher, which goes into much more detail in this material, but here is a summary. Spinnaker was launched in 2015 and revolutionized the way that developers and teams approach continuous delivery at Netflix and at many other companies. The primary abstraction provided by Spinnaker to model delivery workflows was pipelines, as you're all familiar with. In the beginning, all was well and good. We had a few apps with relatively simple delivery flows. Developers were happy. Fast forward to 2020, however, and things look a little bit more like the right-hand side of this picture. Teams have to manage a larger number of apps, which are much more complex. They end up with many unique pipelines, or even if they're using pipeline templates, they find that it's not easy to keep these similar pipelines up to date. And if you're on a centralized team like I am, and there's a new practice you want to promote, you now have all these different places to upgrade. It requires a massive effort and coordination. In this state of the world, developers are obviously not very happy and wonder why this is so complicated, which leads us to a question we often find ourselves asking users when they reach out for support in our support channels at Netflix, but I'm sure this happens at other places as well. What are you trying to do? In other words, what's your intent? The answer might be something like, I'm trying to deploy a Debian package to my test environment. Or maybe something like, I'm just trying to figure out why my pipeline is failing. Oh, and by the way, the person who created this pipeline has left the company and I have no idea how to change it. But in the end, what we find developers really want is simply for things to be easier. They want to spend more time on their code, creating business value for the company, and less time worrying about the details of infrastructure and delivery. When we ask them about the ideal experience, they tell us things like, I want to store my config as code so I can use the same process I'm already familiar with, like pull requests. I want someone else to decide these basics on infrastructure and delivery and keep them up to date. This includes things like standardized decisions on compute resources, instance sizes, security, etc. And I want to easily manage many similar configs. Based on this feedback, we envisioned managed delivery. With managed delivery, you define your infrastructure and delivery requirements as code. You tell us what the end state should look like, and we take care of the rest. Another way of saying this is that you can specify your infrastructure and delivery flows declaratively, as opposed to imperatively, as you did with manual tasks or pipelines in Spinnaker before. For central teams providing solutions to developers, we want to provide a way to share configs as best practices so that people who are the experts in each area can make those decisions on the developer's behalf. We also want to provide tools for these teams to update these codified best practices and safely roll them out. Finally, managed delivery was designed from the ground up with extensibility in mind. We provide pluggable extension spots for others to inject opinions and functionality. Before we move to some more concrete examples of what this all looks like in practice, here are some definitions to set the stage. An artifact is just a version software package that you deploy somewhere. A resource is a piece of infrastructure you may manage declaratively, say an EC2 cluster. The spec is a user supply definition of this resource that specifies the details. Current state is the actual state of this resource in the cloud if it exists. So in the cluster example, let's say you have 3 instances that are M5 large in AWS. The desired state is the state you'd like the resource to be in at all times. So in the same example, let's say you would like your clusters to always have 5 instances. The environment is just a logical grouping of resources. You're very familiar with this concept already. So test, staging, prod, etc. And then finally, constraints are just gates to promote an artifact version into an environment. Okay, with these definitions in mind, here's an example of a declarative resource definition. If you're familiar with Kubernetes, which I'm guessing you are since you're here in this talk, this format should look very familiar to you. Every resource in managed delivery has a kind, which is composed of a group, a type, and a version, and a spec, which is the actual body of the resource definition. Here, we're looking at a sample definition for an EC2 cluster again. So you can see some fields as you might expect, like the launch configuration, the account, and the regions where the cluster will run. Out of the box, if you get open source code from GitHub, managed delivery comes with support for EC2 clusters, security groups, and load balancers, as well as Titus clusters, which run in Netflix's own container orchestration system. But you can extend managed delivery via plugins, which is how we've added support for Kubernetes, as you'll learn more about from Nima later. Declarative infrastructure sounds cool, but here's where it gets really interesting. Once we wrap those definitions in what we call a delivery config. A delivery config is the manifest file used in managed delivery to specify not just your infrastructure resources, but where they live in logical environments and how your software artifacts should be deployed to those environments. It's composed of these three main parts. Artifacts is where you specify how Spinnaker will find your published artifacts. In this example, we have a Debian package named Keel demo, which Spinnaker will look up in the artifact registry. We use some versioning conventions to sort artifacts and identify when a new one becomes available for deployment. Next, we have environments. This is where you map your infrastructure resources to logical environments like test, staging, or prod, as I was just saying. Each environment can then declare one or more constraints for approval of new artifact versions. In this example, we have a depends on constraint, which means that an artifact version will only be deployed to the prod environment if it has successfully been previously deployed to the test environment. We support other artifact constraints as well, such as manual approvals and deployment windows, with more to come. I wanted to touch briefly on how Keel, which is the Spinnaker service that implements the bulk of managed delivery, operates under the covers, because this is another way in which Kubernetes comes into the picture, as we were heavily influenced by the Kubernetes design on resolving drifts before desired state and current state. In essence, it's a pretty straightforward process. We have a loop, and for each resource that we know about, Keel will ask the corresponding resource handler plugin for its current state and the desired state, and then compare the two. If there's a difference between desired and current, Keel will call the resource handler plugin again to resolve the delta. So in the example I mentioned earlier, let's say you have an EC2 cluster that has 3 instances right now, and you set your desired state to 5 instances. So Keel will detect that difference and will ask the resource handler to correct the difference. Once again, I wanted to emphasize that resource handlers are plugins. This means that you can write your own. All right, enough with the theory. Let's see what the current state of managed delivery looks like in action. Here's the brand new environments view. Here you can get an overview of all of your environments and artifact versions at a glance. You can drill down into a specific artifact version by clicking on it. When you do, you can see exactly the state that version was in the various environments. For example, here you can see Keel itself managed by managed delivery. Yep, we dog food. And that the latest version that's at the top there is currently deployed in all three of our environments, test, pre-staging, and main. We also have integration with the source control system, so you can see details about the commit associated with artifacts on the top right-hand corner there. This is a first for Spinnaker, and it gives you great visibility. We're really excited about this. Next, I wanted to show you how a manual promotion artifact flow looks like. As you can see in the UI, here I specified a manual judgment constraint on the staging environment, so the artifact will not be deployed there until I approve. I can do that from the UI, as you can see here, by clicking that button, but a much cooler way of doing this is using Slack. Here you can get a Slack notification that has interactive buttons to approve or reject the artifact promotion. If you're constantly on Slack like we are, especially now with COVID and lockdowns, this makes your life so much easier. Our users love this feature. Next up is pinning. As the name indicates, pinning allows you to pin a specific version of an artifact to an environment, bypassing any promotion constraints. This is another feature that our users love because it allows you to easily roll back in case of a problem or expedite a deployment if you're in a rush to get a hotfix out. Let's say you're in the middle of an incident and you can't wait for the artifact to go through the usual promotion flow from test to staging and then prod. You just need to get it out. This is how you do it. When you click that pin button, Spinnaker will immediately start deploying that version in that environment. If you're familiar with the current experience of rolling things back in Spinnaker, you will understand how much better this experience is in terms of the ease of use and the visibility you get about what's going on. It's just great. And here you see the version deployed and the pin icon over the artifact version and environment on the left-hand side, which makes it easy to spot. The last feature I wanted to show you is what we call marking a version as bad. This allows you to make sure that a version will never ever be deployed in that environment again, not even by accident. So back to our fictitious example of the incident scenario. Imagine that you found a really bad bug in a version that's currently in production, and then you're going to pin a different one to fix the problem. Well, you want to make sure that even if you roll back in the future, you never end up deploying that bad version by accident. So this is how you do it. Once you mark it as bad, this is what the UI looks like. All right. I hope that was exciting to see. I know I get excited all over again every time I talk about this stuff because it's truly awesome. The last thing I wanted to cover is extensibility. As I mentioned earlier, managed delivery was designed to be extensible from the ground up, and it comes with a bunch of plugins or extension points. Here are the extension points that we support today. We have resource handlers, which allow you to implement your own resource definitions. We have resolvers, which allow you to inject your own opinions or smart defaults into the resource specs. Constraint evaluators allow you to implement your own promotion constraints for artifacts. And then artifact suppliers allow you to even build in new artifact types for Spinnaker. With these, the sky is truly the limit for all the new and cool ways in which you can extend managed delivery. And to talk exactly about that, I would now like to hand it over to my friend Rob Hilton from AWS. Rob?
Thanks, Luis. As mentioned, my name is Rob Hilton, and I'm a Principal Solutions Architect with AWS. Now that we have some background on managed delivery, I'd like to explore the relationship between Spinnaker and Kubernetes a bit. To do that, however, I'd like to tell you a story about the way things were back in my day. So gather around one and all, and let Rob take you on a journey into technologies past. In the days of Spinnaker yore, 5 to 10 years ago, the orchestration of infrastructure was a very sequential process. In many ways, it still is. An all too common example is probably one that you're already familiar with, and that's creating externally facing instances on AWS EC2. Assuming you've already created all the appropriate virtual networking, it's a multi-step process. First, we create our security groups, then we create our launch configurations, and then auto-scaling groups, and we eventually create our load balancers. Another word for this process is imperative, meaning that you tell AWS how to create things and in what specific order. It made sense for early deployment toolchains to simplify that process for developers and operators. Many application deployments look similar, so why not allow for the opinionated automation of the creation and management of those assets? Early Spinnaker providers did exactly that. They were abstractions that enabled easy interfacing to nuanced infrastructure providers like AWS EC2 as an example. Luis talked about the pipeline story earlier, and as we learned then, pipelines took things a step further. They allowed you to start stringing together multiple providers and events and effectively say, do these things in this order when triggered by that. And the world was happy. Or so we thought. Over the last 5-ish years with increased adoption of Kubernetes, those paradigms have changed in some interesting ways. If you adopted Kubernetes, you were suddenly defining your infrastructure declaratively, or in other words, specifying your end state. Let's take a look at this example. Here we see some fairly simple flat YAML defined for Kubernetes. Looks pretty clean, looks pretty simple overall. If we segment it down a little further, however, we can see two distinct bits of an application. We see Redis on the bottom, and we see an application that's reliant on Redis on top. Further segmentation shows services, which effectively enable communication to those application bits. If we think about the implication there, we realize that the services, the communication pieces, are dependent on the application in order to function. And if we segment it further, we can see another implicit dependency that the application on top is dependent on Redis on the bottom. But with all of those underlying constraints and implicit references, we don't have to specify any of those things. We don't have to specify that we need our deployments before we need our services. We specify our end state for all of it, and Kubernetes works through reaching that end state on its own. And that's how Kubernetes is declarative. But that raises a question. So how should we use a delivery tool like Spinnaker, and how should it handle Kubernetes in this type of ecosystem? In the first variation of the provider, the strategy was fairly similar to other imperative providers like EC2. Simplify the interface, provide a clean UI, automate the consistent pieces, and make things easier for developers and operators. And this worked really well. In most instances, it provided a much cleaner operation of Kubernetes for users who were unfamiliar with the admittedly complex syntax of the YAML manifests that Kubernetes expects. However, there was a problem with this, and that's that the flexible nature of Kubernetes manifests and the extensibility in things like API versions, as well as custom resource definitions, meant that Spinnaker was either missing functionality at all times or playing catch up with Kubernetes' fairly volatile API definitions. Additionally, it also somewhat mitigated the elegance that comes along with declarative manifest definition. So, with that, version 2 of the Kubernetes provider was born. And the second version fully adopted Kubernetes declarative design paradigms. You as a user pass in whatever Kubernetes manifests that you want, and Spinnaker will deploy them. We're still in a bit of an odd spot though, and that's while the Kubernetes is declarative and flexible, it's also what I like to call declarative in isolation. At the end of the day, we have to remember that Kubernetes is a container orchestrator, and despite all appearances, it's a fairly isolated one. Kubernetes manifests are cluster-bound, meaning that they apply only to a single cluster. It falls to you or some kind of external toolchain to be able to replicate those manifests across clusters or to templatize them so they differ from one environment to the next. Additionally, while Kubernetes can interface with external services to enable extra functionality, testing, interfacing with other infrastructure providers, for example, those implementations are generally provided by third-party plugins that install themselves into Kubernetes, many of which aren't as mature or well-maintained as something like Spinnaker, which specializes in those kinds of flows. So the question becomes, where does that leave us? Our interface point with Spinnaker is declarative, yes. But as Luis showed you earlier, Spinnaker's pipelining tools are still inherently imperative as of right now, relying on you to explicitly define the how and when. In short, declarative plus imperative, confusion. I can hear what you're thinking out there in the virtual ether though. But wait, isn't managed delivery declarative? Doesn't it have a similar API structure? How insightful you are, anthropomorphic slide, and you are absolutely right. In our conversations and collaborations with Luis and the rest of the team about managed delivery and the problems it solves for delivery toolchains, together we found a clear parallel with the Kubernetes world, and thus our collaboration story was born. We have two major things that right now are separated that we can take into account. We have our infrastructure configurations, which can be Kubernetes or otherwise, and they're defined declaratively in a developer-friendly language. And we also have delivery configurations, also defined declaratively and in a developer-friendly language. One thing defines what, one thing defines how. And our thought was that it would be awesome to take this and combine it with this and have a single config that defines our what and how together, or our application. And now, to tell you more about how to help make this dream a reality, here's my esteemed friend and colleague, Nima Kaviani.
All right, thank you very much, Rob. So in the rest of this presentation, I'm going to talk about how to deploy managed delivery and Keel, its corresponding microservice, and then how to enable Kubernetes support for it. As Louise mentioned, you can create resolvers and resource handler plugins for Keel, and they allow you to implement your declarative resources and enforce your opinions when handling those resources. So for Kubernetes, we developed a plugin that introduces Kubernetes resources to Keel and enables you to then combine the declarative definition of both Kubernetes resources and infrastructure resources all in one place and as part of your delivery config manifest. And this is exactly what Rob explained. So the plugin, as you see on the slide, is accessible from the GitHub link referenced on the slide, and you can go play with it. It's open source, and you can also, if you're adventurous enough, you can go deploy it. But before getting into the details of how it works, let's start by looking into how you can have Keel deployed to your Kubernetes cluster and configure it to work with other Spinnaker services. So in order to deploy Keel, you need to use Cleat. Previously, you had to use Halyard to deploy Spinnaker, and I suppose most of you are familiar with how Halyard works. Cleat is being developed as a replacement to Halyard to create and manage Spinnaker configuration files. It works in combination with Customize, which is, for those of you who are not familiar with it, a tool to customize Kubernetes resources. Pretty obvious from the name, right? So the interesting point about Cleat is that it uses the same configuration file that was previously used by Halyard to deploy Spinnaker. Cleat takes the halconfig.yaml file as the input and then generates configuration files to be used with the Spinnaker microservices. So for us to be able to use Cleat to deploy Keel, we first need to modify halconfig and add configurations for a SQL data store, as well as configurations related to enabling managed delivery. As you can see here, as part of the configuration, you can also define what resource types and plugins you want to enable in your managed delivery deployment. For example, in this example that I'm showing here, we have EC2 and Kits resources enabled. So once done, then you run cleat generate on your halconfig file and give it a destination directory for it to copy the generated configuration files into. Okay, so next step is to modify your keel.yaml configuration file that was generated in the previous step and add a reference to your Kubernetes Keel plugin so that Spinnaker can install the plugin as part of deploying Keel. With those configurations in place, you can also configure custom overlays for your Spinnaker deployment and eventually run customized build in your configuration directory in order to generate the Kubernetes resources. You can then pass these resources to your kubectl and you will have your Spinnaker microservices deployed to Kubernetes. All right, so once you have your Spinnaker deployed with managed delivery, you can start using it for declarative delivery. So the idea here is that you define managed delivery configurations as well as your Kubernetes resources in a delivery config manifest and push it to your Git account and then configure Git to notify Spinnaker whenever you make changes to this configuration manifest. Once the notification comes to Spinnaker, Igor, the Spinnaker microservice responsible for pulling artifacts from Git, pulls your Git repo for the latest config, passes the information to Keel, and then Keel stores the new version of the delivery config in its data store. And the delivery config is stored in Keel's data store. At that point, it becomes the source of truth against your Kubernetes cluster. And Keel tries to bring the state of your cluster to match what is stored in its data store. So this is done by Keel periodically running these sync cycles where it actually takes the delivery config from its data store and contrasts it against resources in your Kubernetes cluster, and then checks if there is a difference. If there is a difference, in fact, then this results in Keel creating a task against the Kubernetes cloud provider that will update the Kubernetes cluster with the new version of the resource. Okay, with that, so let's see a demo of how things work. Okay, so for the demo, we're going to keep it short and sweet. Let's start by creating a pipeline, call it MD for managed delivery. This is a Spinnaker deployment that has managed delivery enabled for it. First thing we do for the pipeline, we go to set up an automated trigger for it so that when changes from GitHub come in, it gets picked up by Spinnaker. The type of the trigger is Git, the repo type is GitHub, and then for the user, I choose my username and the name of the project is going to be SpinMD test. All right, we have everything here, we set it up. Next, we move on to adding a new stage. The new stage is going to be import delivery config, and you get this stage if you have managed delivery enabled for your Spinnaker deployment. Now, under manifest base path, we define summit.yaml, and this is to refer to where we are going to store the manifest configurations. So with that, we have everything enabled for our managed delivery setup. Then we go to spinmd test, which is the repo we configured in our pipeline, add a new file. We call the new file summit.yaml. And then for the manifest, we have a very basic manifest that we copy over. As you can see, the manifest has the name of the manifest itself. It has the application name Nima Spin, which is similar to what we have for Spinnaker. Then the environment is a test environment, as you can see, and it deploys to my Kubernetes account that I've configured already. So on the resources, then we have two resources. One is a Kubernetes service, and it actually deploys to my Nima Spin application. It refers to the Hello World application, which is a deployment, a Kubernetes deployment that deploys one instance of my container here, a Hello Kubernetes application. So we have everything defined. Now at this point, we can actually go and you see the name of the service and the name of the deployment are actually Spin Summit. So here I've also configured Keel. You see the logs on the right, and I'm also watching for the pod creations in my Kubernetes cluster. So we go back, and then at this point, I think we have everything. We can save the manifest. Once we save it, you see that actions coming in, requests coming in, and managed delivery is executed. Logs for Keel are rolling, and you see that a new deployment has got picked up. So if you look at the left-hand side, you see that we actually have deployed one instance of the Spin Summit application that we configured earlier. Now, in order to show that you can update your resources, we can actually go back and modify the submit.yaml file. And for example, bump the number of replicas to 2 here. Once we commit changes, you see that new changes come in. And if I go to my managed delivery pipeline, you see that there is an action, logs are rolling. And on the left, if I refresh the screen, you see that there's a new instance of the application that has got created. So if I query again, now there are 2 instances of Spin Summit deployment that are running. So if I look at the services instead of the pods, then we see that there is the Spin Summit service that's also created. And at this point, if I click on the link that you see here, it'll take me to the deployed instance of the application. So if I actually look at it, then I'll see that my Hello World application is deployed and it's all managed through the Keel deployment. All right, that was a very quick demo, and I think we can go back to the rest of the talk. So as for the future work, we have some short-term and some long-term goals for the Kubernetes Keel plugin. We're working with the community to make Keel deployment and also the enabling of managed delivery available to everyone using Cleat. We are very close to make that possible, in fact, and we're hoping that the next version of Cleat is going to enable you to deploy managed delivery and Keel as part of it. We're also working on making the system more stable and the plugin more robust to be used by the community. So hopefully you can actually start using it for your Spinnaker deployments against Kubernetes clusters. Other short-term plans that we have is that we are working on allowing support for customized and Helm resources as part of Kate's managed delivery support. This basically means that rather than the vanilla Kubernetes resources, you will be able to also have resource customizations or Helm templates defined in your delivery config manifest and rely on the Kubernetes plugin to deploy those resources for you. So for the long-term goals between Netflix and AWS, we are working on defining higher-level abstractions for your application specification so that rather than defining or having to define infrastructure resources and Kubernetes resources, you actually have these higher-level constructs to define the specification of your applications, and then Keel will take those abstractions and converts them to the lower-level constructs for Kubernetes or for the infrastructure in order to get your application up and running. And hopefully by that, we're planning to simplify the process of deploying applications even further when you use Spinnaker. All right, with that, I'd like to conclude and open it to questions. Thank you very much.